Today's lesson is 2.4 Trends of Atomic Radius, Part 1. Chapter 2.4, Atomic Size and Energy Levels. We are going to break this lesson down into three smaller sections. We're going to look at the radius trend. We're going to look at the ionization energy, and we are going to look at electron affinity, all as three separate trends. So the first trend that we're going to look at is the trends for atomic radius. So there are two general trends for atomic radius. One, as you go down each group in the periodic table, the size of the atom increases. The second part of this trend is that as you go across from left to right, the size of the atom will decrease. So I have this periodic table here, and it just shows what that trend is. And I'm going to explain in a moment how this works and why does this trend actually work. So as we said, as we move from left to right on the periodic table, the radius will decrease. The radius is actually going to get smaller. However, as we move down the periodic table, as we move down a group in particular, the radius will increase. And we're going to see why in a moment. So as you go down each group in the periodic table, the size of the atom increases. So as you go down the group, the valence electrons occupy an energy level that is farther from the nucleus. Remember that as we move down each period, right? So here I'm numbering the periods. Each period implies a new energy level. So period number 1 here will have 1 energy level. Period number 2 will have 2 energy levels. Period number 3, 3 energy levels. You see where that trend is kind of working. So that means as we move down, we are going to increase by an additional energy level. And this will result in less of an attraction to that nucleus, as we're going to see with the second component of this trend. So the inner electrons found within the inner energy levels will block, they will repel the valence electrons that are being attracted by the nucleus. And we're going to see what that trend looks like with the diagram that I'm going to show you. So here we have two elements that lie, or should I say two atoms that lie directly one above the other. So sodium, if you look at the periodic table, is just above potassium. So notice here with the diagram, we have greater number of electrons on the innermost energy level, and this one electron, the one valence electron found in potassium, is further away. Why? Because what is happening is these electrons on the inside will repel that one lonely valence electron. So this nucleus does not have the ability to pull them closer. And as we move down the group on the periodic table, we add an additional energy level, thus causing a larger radius. But when we go across the periodic table, the atom decreases. So as we're moving from left to right, the atom's radius is going to decrease. And so the size of the atom decreases because the positive charge found in the nucleus of the atom increases across the period. So we have additional protons, or we have more protons as we move from left to right on the periodic table. So they have the ability to pull more electrons. But remember, as we said with the previous part going down, that we've got the repulsion of the inner electrons, and those inner electrons really do repel. However, it actually because of that greater nuclear pull, we are able to overcome the repulsion that's occurring on those inner electrons. And so we're going to see that here with this diagram. So I've picked 3 atoms that lie within the same exact period. And these are all atoms in period number 3. So we've got sodium, followed by magnesium. Magnesium gets a little bit smaller. Why? Because if you look at it, right, 12 protons as opposed to 11 protons. So this 12 protons has the ability to pull up to 12 electrons. So the minute we try to pull an extra electron here, all of a sudden it is going to overcome the repulsion that is occurring within these energy levels, right? They're repelling the valence electrons, but because this nuclear core has more protons, it will overcome the repulsion that is occurring by these electrons. Remember, electrons all share the same charge, right? Negative charges. Like charges repel one another, opposites attract. So this opposite charge is trying to attract these electrons, but this electron, as we see here, this electron is being repelled by these inner electrons. And that repulsion becomes less and less as we move across the period. So all of a sudden, notice here, we've got 17 protons. We have the ability to pull up to 17 electrons, causing less repulsion here. They're repelling, they're trying to repel as much as they can, but this nuclear core has too many protons to pull them in.
I hope you liked this video. If you did, do not be shy to hit that thumbs up button. And while you're clicking the thumbs up, click on that subscribe to stay tuned to my new videos. Thanks for watching.